Number 4, we are taking the limit as x goes to 0 of 1 minus cosine of 3x over 16x squared. So if you plug in 0, it's going to be 1 minus 1 over 0, which is equal to 0 over 0. So it is our indeterminate form, which means we want to use L'Hopital's rule. So if I copy my limit, and then I want to take the derivative of the top and the bottom separately. So sine of 3x times 3 all over 32x, which is equal to the limit as x goes to 0 of, I'll put the 3 out in front. You don't really need to show this if you don't want to. And 32x. And if you plug in the 0 now, we actually still get 0 over 0. So we haven't really, at least it doesn't appear, improved our situation. But because this is 0 over 0, we are allowed to use L'Hopital's rule again. So anytime you get 0 over 0, or an indeterminate form, then you are allowed to use L'Hopital's rule essentially every single time you get that. So if I do that again, then I'm going to get 3 cosine of 3x times 3 over 32, which is equal to the limit as x goes to 0 of 9 cosine of 3x all over 32, which is going to be equal to, if you plug in 0, cosine of 0 is 1, 1 times 9 is 9, and we get that over 32. So 9 over 32 is going to be our solution.